My name is Art Panasian. I'm with the Department of Labor Standards, and it's under the Executive Office of Labor and Workforce Development. And today we're going to talk about accident investigations. So let's get to it. Right, now the things that we want to take away from this training, the most important things is we're going to do these 4 objectives. We're going to talk about a little bit about preserving the scene, if you can, how to document and collect information, what type of information to collect. We're going to try to identify contributing factors that contributed to the incident. And then once we identify those factors, we want to figure out a way to implement corrective actions that would prevent that from happening again. And that's why we investigate accidents and injuries. Accident investigation can also be called incident investigation because an accident is usually a physical injury. An incident is any kind of bad outcome that happens, and you want to investigate them all because a close call or a near miss is just an accident that is going to happen if you don't do that investigation. A guy called George Santayana back in 1863 said, "Those who cannot remember the past are doomed to repeat it." And that's the real guy. So, and that's true. Oftentimes we say, well, you know, OSHA regulations are considered written in blood. And the reason they say that is that all of the regulations that we have now have come a result of serious accidents, injuries, and fatalities. And that's finding the hazard the hard way is after somebody's seriously hurt or injured or killed. And that's why we have regulations. That's how we also get permissible exposure levels for things like chemicals. When they notice people are getting sick and throwing up and passing out, they said, well, that's a threshold limit. That beyond that limit, people get sick and have a hard time staying vertical. So that's where regulations come from. If they come from accident investigations. An accident investigation is a reactive method, which means something bad has already happened, and now you're trying to learn from it. So that's the whole idea of learning from the past, so you don't repeat it. Now there's a more proactive way of doing things, and that's called job hazard analysis and risk assessment. That's where you look at the work you're going to do, break it down into steps, and say what can possibly go wrong, and you come up with a plan. A lot of times we hear in the news, well, there was a freak accident here and a freak accident there, and it seems to imply that accidents cannot be prevented. It's like an act of God, or it's a fate or destiny, and it just happens. Freak accidents are things, if you're going to look for a definition, these are things that are generally not covered by your life insurance. These include acts of war, acts of God, getting struck by lightning, unless it's job related, or getting hit by a meteorite, or a chunk of Skylab falling out of the sky and just hitting you. Well, your number was up. Hard to prevent that. There's also intentional self-injury or suicide that can't be anticipated too much. So we like to say, let's investigate all incidents, not just accidents. So an incident is any bad outcome that's the result of any kind of contributing factors acting together to produce that bad outcome. So incidents can be injuries. They could be property damage. They could be a close call or a near miss. You should investigate them all. And the idea is that you can anticipate and prepare for and prevent, with some kind of thoughtful planning and analysis, most accidents and injuries and incidents. People don't plan to fail, but oftentimes they fail to plan. And generally failing to plan is not an accident. It's just simply easier to do nothing. And that's not acceptable anymore. So what do these numbers mean? 9.8 million, 60%, 100,000, 3,700. Well, 9.8 million is what was spent in the last year under the executive office for workers' compensation. And we want that to go down because the 60% is that showing that we're, for the number of hours and man hours, person hours that we work, We're about 60% higher than the surrounding states and even the private sector in terms of injury rate. That's a rate per 200,000 hours worked. The average person works about 2,000 hours a year. Well, me a little less than that, but the average person is doing 40 hours a week for 50 weeks with 2 weeks vacation. So that's 2,000 hours. And if you have 100 people, that's 200,000 hours. So that's how they figure out, well, what's the percentage of people getting hurt? 100,800 is was our high water mark of what was paid out for a claim. And 3,721 is what the average cost for workers' comp is for the average injury. Those are the numbers. What were some of the most expensive injuries in fiscal 14? Well, slip on floor, believe it or not, was the 100,000 one. Slip on ice was a $76,000 claim. Trip on the sidewalk. So these aren't very, these are kind of run-of-the-mill slips, trips, and falls. Lifting, ergonomic issue, hurting the back, very common injury, very expensive to rehab a disc versus using the right tool. Assaults by inmates, staff, assault by patients in a hospital. Someone might have dementia or Alzheimer's and can't remember where they are, and they panic and they strike staff. So these are all expensive injuries. Electrical shock and amputation are more the ones that we kind of think are the more common ones, but they happen as well. Now, natural disasters exist, and weather and environmentally related ones they're hard to anticipate, but they're not impossible. And actually, some of the weather, some of the slips on ice and snow and stuff, are weather related. But these are the more freak accidents that happen. They're hard to anticipate. But we still, if you live in Kansas, you're probably going to have a tornado or a lightning storm shelter, because these things happen more frequently. If you live near a river or near the ocean, which a large percentage of people do, you'll know that you can look up to 100-year high water marks or flood zones, and you don't build there. So you can anticipate some things. A couple of years ago in Fukushima, Japan, there was a tsunami, and luckily they did have a little bit of advance warning because they have sensors in the ocean, so they can sense things and let people know to get to high ground. But still, even then, it was a disaster because a nuclear power plant ended up getting swamped, and nobody saw that coming. Even in areas where you have homes near the shore, like in North Carolina or whatnot, on the Outer Banks, they're going to build houses up because they know that 100-year storm is just around the corner. Now, volcanoes are real unpredictable. One minute, Mount St. Helens was there, and a couple of minutes later, a giant part of it blasted off, and ended up killing some people who were taking photographs. But you could still plan and make good choices. So good choices does require some planning. Even in our homes and in our workplaces, we do plan. What are we going to do in a fire? And that's called emergency planning. We have smoke alarms, we have fire suppression systems, we make sure we have portable fire extinguishers in the workplace. So we do plan for the worst. And the same thing should happen for workplace activities. You should plan ahead of time what's the worst that can happen. Most occupational injuries, luckily, are not the result of natural disasters, although some are weather related. Slips, trips, and falls on ice, snow, wet floors, grease, oil. There's backs and muscle sprains from lifting, shoveling, snow blowing, equipment maintenance. A lot of times injuries like ergonomic injuries happen because we overestimate our strength and we underestimate the forces involved in the work we're doing. There's lacerations. You could be working with things that have sharp edges like chainsaws, meat slicers, blades. We can't anticipate when we're going to work with those things. Amputations happen with snowblowers, lawnmowers, any kind of whirling blades can cause amputation. So moving parts, we guard them so we don't get our fingers and hands and feet near moving parts that can do damage. There's burns. You could be welding, torch cutting, doing auto repair, have a hot muffler, and the funny thing about a hot muffler, it looks about the same as a cold one. So but you have to be able to anticipate when can I see hot stuff, and what should I be wearing so I don't get burned. Same thing with electrical shock. I mean, you can't see electricity, you can't see the electrical hazard. That's why we always de-energize circuits and lock them out before we start taking metal screwdrivers and unscrewing things. The other thing that happens occupationally, that are quite a few of them are these days, are assaults and violence. Whether you're a corrections officer, a police officer, you're working in a nursing home, you could be working in a school. So that's something that can happen. And there's also struck by types of injuries from getting struck by vehicles and whatnot. So again, our whole purpose here is we've got to remember these 4 things, that once you have an incident and you're going to investigate it, try to preserve and document the scene. A camera is very helpful with that. Collect information. You're going to be asking a lot of questions or writing it all down, and you're not sure which ones are the more important questions, but you just keep on asking those questions. You want to get down to the root cause of the thing or the contributing factors that contributed to this incident. And then you want to implement your corrective actions. This is OSHA's systems approach. I didn't invent this. I do take no credit for it. I copied it right from the OSHA website. So OSHA does have stuff, very good checklists and whatnot on accident investigation on their website. That's available for free. So why do you investigate? Well, the main thing is to prevent recurrence of injuries, illness, and property damage. It also is great to save lives. It saves money for both the employer and the employee. This is a win-win that you don't come across too often. It demonstrates the management's commitment to health and safety. Promotes a positive workplace morale, because people are happy to work at a place where they don't worry about getting killed. It improves management efficiency, because every time someone gets injured and they're out on workers' comp for a month or two, you might have to get a temporary person to fill in for that work, and it it could slow things down and mess up your efficiency goals. So the root cause is that underlying reasons that unsafe conditions existed. So oftentimes it's a problem with procedures or rules that weren't followed, and you have to find out, well, why weren't they followed? It's a reflection on management, and it's a reflection on your pre-thinking of design, planning, organizational, and operational failings. Incidents often happen like a domino effect. There's usually several things that fail that eventually cause that catastrophic end. But why we investigate is to find what's the problem with our policies and procedures. We're not really looking to give people mental health coaching. So what do we investigate? We're going to investigate programs and procedures, not behaviors of individuals. Why? Because we could change programs and procedures. Not so easy to change behavior of individuals. What organizational factors created the precondition that allowed a failure to happen? That's what we're looking for. Was there a clear procedure? Had anyone done a hazard analysis beforehand? Were there instructions to follow? Like if we have to replace this macerator, well, we have to de-energize here and lock it out there and go back and use these tools. If you have a procedure, it's less likely people are going to improvise and do dangerous things. If you're using equipment that was designed by an engineer and manufacturers, they usually have user guides, and that manual should always be present, and you should follow that manual. Because a lot of times, that's how they find out what's gone wrong with their product, is people sue them, and because someone got injured, and then they'll put something in there. Hey, no, when you're changing this, be careful of that, because we don't want a bad thing to happen. So always check. If you have big machines that you might have to do maintenance on, make sure that you do have those manufacturer manuals. Now, what happens if you don't get to the root cause? Well, this is a lot like those of us who do weekend landscaping. If you don't take care of those dandelions and get them out by the root and just mow them over, pretty much you never get rid of those dandelions. And it actually leads to proliferation of dandelions and usually more problems. Because if you don't deal with that root cause, it's going to happen again. It's not a matter of if, it's just a matter of when. So again, we want to preserve the scene as best as possible. Now, if somebody gets hurt and they're not dead, then you want to get them help. So that's the first priority, is getting people first aid and making sure that they're taken care of. And then the best you can, preserve the scene. You might want to set up cones, put up the caution tape. Even you might have to post a guide there to prevent equipment from being altered or taken away. Interview any witnesses and use your notes or record with their permission as soon as possible, because short-term memory is what it is, and it's a terrible thing to waste. Find out what happened immediately. And ideally interview multiple witnesses separately, if there are multiple witnesses. Interview them in private, because they may not want to speak openly in front of supervisors, or they might be in fear of punishment if they did something wrong, or they felt they were doing something they weren't supposed to be doing. So let them know that you're not trying to get them in trouble, that you're just trying to find what happened. So find facts versus fault. That should be your focus, and find those things that contributed to the incident. Sketch the scene if photos aren't available, but these days good digital photos are very, very useful. And then make notes of your photos. You might have to take a picture and say, later on, I don't know why I took this picture. So if you take pictures, you should review them soon afterwards and make notes on each of the pictures so you remember what you were doing. There are incident checklists that are on that OSHA site, and I think we'll also load them up, hopefully. They're going to have things like who got injured, what's the employee's first language, their job title, are they full, are they part-time, are they a seasonal employee, did they get training, how long have they been employed, what happened, what was the type of injury, was it a cut, a burn, a contusion, which is something like a bruise, was it a sprain, did you get caught by or struck by something, put the date and the time. The time is very important. Did it happen first thing in the morning, right when they checked in? Did it happen late in the afternoon? Were they working overtime? Was it an emergency situation? All these things can contribute. And you want to put down where the exact location was. Try to describe the events. Like, for example, crossing guard was stepping into the crosswalk when he was struck by a vehicle heading east at 803 on Speedway Street. That's your description of the event. Collecting information. Always, again, if you're dealing with equipment that caused injury, get that equipment manual. And if not, you can get it online almost always. Look for industry guidance documents. ANSI standards are consensus standards that are often very good. If you're dealing with a different type of machine, whether it's a crane or a front-end loader, they're going to be industry guidance documents, and there's going to be equipment manuals. Then you should also look, what are the company policies that were related to this accident? Look at maintenance logs, look at training records. When was the last time this person was trained? So if someone was exposed to a burn, did they know how to use a portable fire extinguisher that was 10 feet away from them? Those are all important things. So that's where training records get important. They're usually not important until something bad happens and say, hey, did this guy get any training? This person get any training? Look at enforcement policies, records, and audits and monitoring. If nobody's monitoring any work in your shop, and if nobody's been told, no, that's not the way to do it, well, then people are going to leave things up to their own best judgment, and sometimes that's not the best way to do it. Note the weather. Was it sunny? Was it raining? Was this in the middle of the winter? Was it in the spring, in the fall? Was it snow, hail, temperature? Is it very windy? These all can have an effect on the accident outcome. Basically, you want to be like a journalist and do the who, what, where, when, how. So some of the who's questions were: who was injured, who saw what happened, who was working with the person, who was supervising him, who was instructing them, and who was monitoring the workplace when this happened. Some of the what questions is, well, what happened? What was the injury? What part of the body got injured? What was the employee doing right before he got injured? What he had he been instructed to do a certain thing? What tools were used? What machine was involved? What task was he doing? Were there any precautions given? Hey, look out for this, look out for that. Were any precautions used? How about personal protective equipment? Was it required? Had someone done a hazard analysis and say, well, if we're working with hot metal when we're welding, we should be wearing thick leather fireplace gloves, picking up the metal so we don't burn our hands. So did someone say wear this type of glove? Was it specific? Did the employees who witnessed the accident, what did they do and how soon did they do it? Sometimes when bad things happen, people just freeze and they freeze. They don't know what to do. So that's important as well, is to see, well, how fast and how efficiently was the emergency management folks called, and is that system working? Some of the when questions is, when did it occur? What time of day? Was it, what time did they start work? When were they assigned that task? Were any hazards identified using a job hazard analysis? Check with the supervisors. When was the last time they checked in with the employees and to monitor to see what they're doing? Did the employees sense that there was something wrong or different about the machine? Was it making a strange noise? These are all important when questions. The where, the why, and the how is, well, where exactly did it happen? Where was the employee positioned? Where were the other witnesses positioned? The why questions might be, why was the employee injured, do you think? Did he do it that way all the time, or was he doing it differently? Was he working alone? Was he wearing the protective equipment he was supposed to wear? Was he warned about the hazards to avoid? Why? Was he in that position? Or why was he using those tools? Why didn't he check with the supervisor if something was unusual? And again, some of the how questions: how did the employee get injured? How could he have avoided being injured? And could any information have prevented this? So here's an example. During floor stripping and waxing, an employee at a state hospital began having chest tightness and difficulty breathing. He was brought to the emergency room and he was treated for and diagnosed with occupational asthma. So the machine used to apply the floor stripper sprays a product that's diluted with water in front of a rotating brush, and then a squeegee pulls and vacuums the liquid into a holding tank by suctioning it up, vacuuming it up. The safety data sheet indicated the floor stripper had 25% ethanolamine, 25% 2-butoxyethanol, and 10% sodium benzyl alcohol. So these are all chemicals. So that's the minimum floor scrubber he was working on, and he was a guy who got dizzy. So you say, well, let's take a look at these sheets. What do they say? Well, 2-butoxyethanol has an OSHA permissible exposure limit of 25 parts per million. That means if you breathe more than that, you're probably going to get sick or it could affect your health. And it also says, be careful because this could be absorbed through your skin. So these types of things on the SDS sometimes will help you ask the right questions. Was he wearing a pair of tennis sneakers, open-toed sandals? Did he get any of this stuff on his feet? Did it get absorbed into his skin? Did he breathe it in at all? Is the machine creating a mist? Monoethanolamine has a permissible exposure limit of 3 parts per million over 8 hours. And benzyl alcohol has a American Industrial Hygiene Association time-weighted average of 10 parts per million recommended exposure. Now, if you spread gallons of this on the floor, do you think there's any chance that you might see 3 parts per million in the air? Well, probably is a pretty good chance. Well, what does the sheet say to avoid breathing these chemicals and getting asthma? Well, it says use appropriate engineering controls. Well, that's not a very specific thing. What's appropriate? Well, you have to use the appropriate engineering controls to keep the employee exposures below these recommended or statutory limits. So use adequate ventilation. Again, that's not a very specific thing. Whenever you see something like adequate ventilation, it usually means open doors and windows and put a smoke ejector fan in there, because this stuff can and will probably make you sick if you breathe it. Now, those machines, to be fair, that floor stripping machine is designed to minimize the amount of mist that gets into the air. But maybe there's something that the machine wasn't working well, or maybe the spray was going off and wasn't getting collected. So those are things that go into your analysis. Were they using appropriate skin protection? Was he taking some of that same solution in a spray bottle and then just spraying it for special hard to reach stains and whatnot? That can happen. So these are the types of things that in this type of incident you want to be asking all those questions. Oftentimes, any information you get will stimulate more questions, like, did anyone review the floor stripper prior to using this product? Are there any greener or less toxic stuff we could use that has maybe detergent in it versus monoethanolamine? Have there been any other reported reactions to this problem? Has anyone else who've used this had problems? Has anyone else reported they're getting skin rashes or sore throats or burning eyes? Did the person using the machine get right to know training? Does he know how to read a safety data sheet? How often are you supposed to get right to know training out there, folks? Once a year, right? And for state agencies, now you're covered under hazard communication, which is basically the same as right to know. And under the OSHA hazard communication, they just says that you have to get initial training. But if you haven't been trained since the Reagan administration, it's probably time to get a refresher. Even if it's not in the OSHA regulations, sometimes it's good to review things. So asking yourself, were they wearing appropriate protective equipment? And who figures that out? Well, maybe when Joe does it, he wears a dust and mist mask, but the other guy doesn't. So you have to ask, well, do we have any policy? Should we be wearing them, or is it optional? So those are the kind of questions you ask. And the other thing is, do we have to strip the floors every month? Or maybe we don't have to strip. There are actually other methods where you actually use a detergent, scrub and clean, and reapply more stuff. So, the whole idea, sometimes you got to ask the question, do we really have to be doing this? So again, even if you've done a job hazard analysis, it may have not been effective. You could still have an accident. So you do a job hazard analysis, and sometimes it happens. Just hold the phone 1 second. Okay, we're back. Okay, so if you could have maybe you had a hazard analysis, and maybe it was done a long time ago, but a job hazard analysis is something that should have found those hazards before they happen. And again, just to review real quick, a job hazard analysis is you break the operation into step-by-step distinct parts. Ask yourself, what's the worst that can happen? And, what can I do to protect my employees from getting injured? Using engineering controls, protective equipment is a job safety rule. So let's say this was, you come across the president of a college is having the house renovated, he's putting a new roof on, and you're the safety person, and you drive up and you see this. Well, you could probably see a number of things that don't seem right. The ladder doesn't seem to be as high as it needs to be, because trying to come off the roof onto that ladder, you'd have nothing to really hold on to. And then you see that the guy isn't wearing a harness or fall protection. He's got his auto nailer gun, because that's what that air hose is, the red hose in the picture. But you say this doesn't seem to be the way we had it on paper. So again, the idea is he has to climb the ladder, install a fall protection system with a retractable lanyard, full body harness. Then he's supposed to pry off the shingles with a shovel or tool and slide them off the roof onto a tarp. And then someone down below is going to hand place that waste into barrels and transfer it to a dumpster. Then they're going to carry felt and tools and shingles up to the roof. Hopefully they have something that will automatically elevate those up to the roof. Unroll the felt, staple it down, fasten the shingles with a nail gun, clean up, and go home. So that was all your discrete steps. And then you come up with the job rules that you want folks to follow. And what's the hazards? Well, you can slip and fall right off that roof if it's a sloped roof. The nail gun these days, they're electrically powered. I mean, they're air powered. And if you double shoot a nail and one nail hits the nail head of another, it can come ricocheting back into you. So if you're not wearing glasses, it could hit you in the eye. It could also, if you just hold the trigger down and just push down the spring in the front, it'll shoot a nail every time you push that spring up and down. So if you zip tie that trigger to if that thing starts to slide off the roof, it could start shooting nails all over the place into you. And it does happen, as the x-ray on the right hand shows. The other thing that could happen is getting on off the ladder. It could slide to the left or the right. So you do want to secure that so it doesn't slide. And then you want to make sure you have the right size ladders. The person in the lower right is trying to going on that top step where the big OSHA letters say do not use this step because it's made out of plastic and it'll break and you'll fall. So you got to use the right equipment for the job. So again, what's the worst that could happen? On a pitched roof, you could fall and lose your balance, and if you fall 10 or 15 feet to the ground, there's a good chance that you can have a very serious injury, or you can die if you stick the landing on your neck. The bare plywood and the rolled tar paper is slick, and you could slip and fall and then roll off the roof. The nail gun can double fire and ricochet, so you got to be wearing safety glasses. If the nail gun slips and falls, if it's in fully automatic mode, it'll keep shooting nails until it comes to rest. While you're on the ground, falling material can strike you. That includes tools and nail guns that are sliding off the roof. And so you do have to wear head protection. And hand and foot punctures can happen. You could be stepping on a nail, so you want to make sure you're wearing the right shoes and whatnot. So these are all the different rules that can prevent injuries. So you'd want to investigate if somebody went out there and had a bad injury. So you want to make sure that ladder goes past the landing by 3 feet. You want to use slide boards that are in a 90-degree angle at the roof, 2x10, not a 2x4 on the side. That's just a speed bump. You'd want to make sure that they're using personal fall arrest systems always, and there is some reason they're not using them. Find out what that is. Don't modify any safety mechanisms on the nail gun. If you look at the manual, it's not going to say to do that. Don't zip tie it or duct tape the trigger down. You want to be using puncture-resistant gloves for your holding hand, substantial boots, maybe a foam kneeling pad so you don't kneel on a nail head and destroy your meniscus or whatnot. So what would be contributing factors if you found somebody on the ground had already broken their leg? Well, no fall protection, or maybe the fall protection system wasn't adequate. There was a slide guard up there that was a 2x4. That's really just a speed bump. It's not a 2x10 at a 90-degree angle. It's not even at a 90-degree angle. If a gun is in fully automatic mode, that's very dangerous. And it may be, if you ask them, they'll say, well, everyone does it like this. And I've never heard a supervisor tell me not to do it that way. And that's, part of your investigation. They might say, well, it's only a short job. I'm just doing a roof repair. I'm not really putting the whole roof on. And, the location moves very frequently. Or in some cases, they do a roof job in one day. So they just figure, well, we'll maximize speed and at the cost of the safety. So when you're doing an accident investigation, don't add insult to injury. Just trying to stick to the facts of what happened, where, when, how, and then multiply ask that times. Why did we make that choice? Until you find all the contributing factors that together are going to be your cause. and then address that cause by modifying your safety procedures and equipment and protocol. And maybe you have to modify your job hazard analysis. So let's say this roofer ended up with 6 nails in his head, 1 in his eye, and he suffered a broken leg when he hit the ground because the nail gun was in fully automatic mode, and while reaching for the shingles, he slipped on the tar paper, lost his balance, and slid off the roof, and the gun discharged until he hit the ground. He was wearing his steel-toed boots, though. He didn't have any safety glasses, and no personal fall arrest harness was evident. But luckily he lived, and he will recover from these injuries, and hopefully will learn a lesson from investigating this incident. And probably a lot of lessons, because there wasn't a lot of safety involved in this roofing accident. Sometimes contributing factors include faulty beliefs, like, well, I didn't think I'd get hurt, or I didn't think I'd get caught. Nobody's ever monitoring what we do. We're just told to get it done. It won't happen to me. These are all faulty beliefs. He didn't think management really cared. Taking the extra time slows me down. I don't like going slow. I don't like doing it that way. I don't like the way I look in safety glasses. These are all just faulty beliefs, but they could also be contributing factors. Safety equipment is sometimes uncomfortable. Maybe it's too hot for that. Maybe my safety glasses were fogging up, or it's too cold, or they don't fit right. It could have been equipment failure. We've seen ladder accidents where the ladders actually were damaged. So you always inspect equipment before you use it and make sure it's in good shape. And some people think, well, it's not my job to maintain equipment or to check it. It is, because it can make a big difference. And it's not okay to bypass safeguards like the trigger guard on the nail gun. It's never okay. If you think that I'll just get a bungee cord and fix this with duct tape, that's not, usually something bad's going to happen. So a lot of times, what we oftentimes find in the field is not really a great mystery as to why we had an accident. To be Columbo, a lot of times it's pretty simple. Maybe they never had a job hazard analysis done, and they weren't wearing the right equipment. And why didn't they do it? Well, I never thought, I thought safety was just common sense. But there is an OSHA regulation that requires you to do this. And if again, regulations are because they're written because people have gotten hurt or injured or killed. And that's why those regulations are there. It's not to make your life miserable or harder or make it a hurdle. It's because if you don't follow those things, that people are going to get hurt. So it matters. It could be a matter of life and death if you don't work safely. And that's why we investigate all incidents. If you have a good job hazard analysis, then you have a very low chance of something going wrong. So again, when you're doing hazard analysis, you ask them to when you're doing the investigation, ask the victim to break down the steps on what they were attempting to do just before they got hurt, and determine the choices they had and why they made the ones they did. Determine if they were following their job hazard analysis protocol, or were they just using their own protocol. And if not, why not? There are reasons, and that's what your job is to identify those reasons, not to judge their behavior. This was an accident where an oxyacetylene torch exploded. The person was cutting away a guard that needed to be replaced, and it was fastening as the fastening bolts were stripped. So he was going to just weld that guard into place and forget about the bolts. He had a portable abrasive electric grinder to clean and smooth the welded area, but he didn't have a fire watch established or a personal portable fire extinguisher. That's what a PFE is, portable fire extinguisher. And when do you need a fire watch? Anyway, well, anytime you're doing any kind of hot work where there's within 35 feet of the area that you're working, there's anything combustible. That includes wood walls. It could be cardboard or actually corrugated board, boxes. It could be paper. It could be a trash can without a cover on it that has rags in it, or paper, or Dunkin' Donuts. paper, empty cups and stuff like that. So anytime you're doing hot work, there's a 35-foot perimeter around it where there shouldn't be any combustible material. If you do have combustible material that's going to be difficult to move, well, that's when you need a fire watch. And a fire watch is basically a person standing around with a fire extinguisher looking for small fires and embers that might be happening from the sparks and molten metal that's flying off of your procedure. So in this case, obviously something went wrong, and both the acetylene tank, which is on the left, and the oxygen tank, which is on the right, the acetylene tank actually exploded, and that's not supposed to happen on these tanks. They have a mode on them where if there is a fire in the regulators and at the valves, they're supposed to discharge all of their contents before they explode. But in this case, the tank did let go. So what happened? So actually, I should probably go back one, because I think I might have. So again, so he had he cut away the guard, and he torch cut it away, and then he was going to use he uses his MIG welder to weld it on, and then he was using an abrasive grinder to smooth the weld. So what happened was he shut off the gas at the gun handle, but he did not go back to the lines and shut off the regulators for both the oxygen and acetylene and then bleed out the lines, which the manufacturer said, well, that's what you do if you're done welding. He MIG welded the new guard, and then he proceeded to grind on the weld. Now, the grinder, you could see in the picture he was using did not have a guard on it because he was using a wheel that was too large for the guard, so he took the guard off. Now, without the guard, it's dangerous in a number of ways. One, in that the wheel can just shatter and come flying at you, but it could also not direct the sparks away to a safe place. So the hot sparks happen to burn a hole into the gas line, which is the red and green line that you see next to the grinder. And if those lines don't have what's called a backflash arrestor in place, then that fire can go right back into the line and ignite back into the regulators. And that's what happened. So now Joe sees some fire happening at the hoses, and he runs to get a fire extinguisher. And then he changes it to a skirt. No, he didn't really do that. But in the picture, there's someone with a fire extinguisher. Now, if that fire extinguisher isn't right on hand and you have to run to get it, that allows the fire to double in size, and that's when you have an explosion. So some of the why questions you might ask, well, why didn't we require that a fire extinguisher is present? Because maybe if someone was watching, they would have seen the sparks starting to hit the hose, and they could have moved the hose, and that could have, anything that interrupted this cascade of bad events could have prevented this accident. So then the other why is, well, why don't we have a fire watch set up every time someone's welding or torch cutting? Well, that's what the regulation says. Well, why don't we do that? Well, why didn't he shut off the regulator and bleed the lines like the manufacturer says to do? How long would that take? A couple of seconds, maybe half a minute. How come we don't have backflash arresters on these the green and red gas lines? Did we ever have them? Oh, when we changed the hose, we took them off because they were attached to the hose, and we didn't think we needed them. The thing works well without them. How often do you inspect the hoses for signs of leaks? How much damage is too much damage? You could have sparks and molten metal hit those hoses, and you might get a little black mark. Well, how do you know when it's bad enough? Well, someone should be trained is to say, well, let's look at the hose, bend it. If you see lots of dry rot cracks happening, time to replace it. So, again, questions, be good questions. How do you test the regulators and hose for leaks? Do we have spark curtains? Were they set up? If not, why not? Where are they stored? What condition are they in? Other questions? Well, why was the guard on the angle grinder missing? Who took it off? Do we still have it somewhere? Oh, was the wheel that we're using too big for that grinder? Is that the one that it came with? Is that abrasive wheel approved for that type of RPM? So again, even if this accident didn't happen to have the abrasive wheel exploding and getting shrapnel from that, well, maybe you've found something else that you need to address. So these are all good questions that could come out of a thing like that. Things to avoid is the blame game. You don't want to say, well, how come anything that bad happens, it's always Joe. He's such a, he's just accident prone. Why did you use the torch? You should have used the Sawzall or something. So no name calling, insulting intelligence or thought processes. There's plenty of blame to go around. It's usually we want to look at what was the process, not individual behaviors. Hindsight is always 20/20. Yeah, looking back, we could always have done something slightly different that would have prevented the whole thing. You could have said, you don't want to say, well, why didn't you think to jump in the front end loader and snuff out the fire with 5 yards of sand? Well, that might have worked. But again, hindsight is 20/20, and most of us don't have eyes tattooed on the back of our head. So again, it's very easy to see after an incident ways you could have prevented it. But the important question is to ask, well, why did this happen? Once you've determined the cause of the thing, you have to make a rule to prevent that from happening. Even if there's no OSHA reg, you make the workplace rule for your workplace that this is something we do a lot and it might happen again. So let's make sure that we have the rule in place, and then monitor if people are complying with the rule. Communicate the results back to the employees. Hey, this is the way we want it done from now on, and take steps to ensure that there's compliance, that they're actually doing it. Start with a positive, friendly reinforcement, and then you have to get progressively tougher. So if no one's looking, does a rule get broken? You'll never know. So that's why you do have to do the workplace monitoring. Without monitoring and enforcement, there's not a lot of incentive for compliance. Now, obviously, that wouldn't be my 97 Toyota that would get that speed, but it can happen. Communication is a key. If you don't know the rules, sometimes you find hazards the hard way. I'm going to show you a clip in a sec. In this clip, one person opens the hinge trapdoor that goes to a stairway to the basement, and they failed to let the other tech know that the floor hole was open, and they failed to guard it. Now, there is an OSHA reg, 1910-23, talks about floor holes, and if you have a hinged floor opening, if it's open, then it must be guarded with a standard railing and a toe board, so that you don't kick tools and stuff down on the person down below. But wherever you're working, you do always have to be aware of what's happening around you, especially when you're backing up. It's best to always look where you're going and go where you look, and report any close calls. So let's see what happened here. Let's see if I can get this to play. Okay, this happens to be in a bar workplace, so it's not probably the best example to talk about state and municipal employees, but in this bar, they were going down below to the basement to get supplies. And now the person does not see the floor holes open, and they go down the floor hole. And so that type of thing can happen. So anytime you open up a floor hole, you do have to protect it, because this could happen. All right. So if you had, this is what an OSHA compliant hinged hatchway would look like. And these are more common up on a roof type level. And this hatchway actually is going to be raised up by a few inches, for rain and water intrusion purposes. But if you open up a hatchway to a roof, it has to be guarded while that hatchway is open. And they do have portable handrails and stuff for that. Now this one's going to have a chain that goes across, so once the fellow steps up onto the roof, he's going to rechain it so that somebody else who's backing up or walking doesn't fall down that hole. And they have things like spring-loaded gates. So again, just to recap, we want to preserve the scene, we want to collect information, sometimes we want to do research, we want to look at the owner's manuals, we want to identify contributing factors, and you want to implement changes to policies, procedures, and programs to make sure you stop recurrence. That's the whole idea of doing the investigation. We've already had a bad outcome, but you can still learn something, so you're turning a negative into a positive. So we want to do that job hazard analysis, again, maybe review it and improve it. So if you do have questions about some of the things that we talked about, my personal number is right down there, 626-6470. I am old school. If the phone rings, I pick it up. Sometimes I regret it, but I will try to answer your question. And if I don't know, I'll ask Steve or someone else. Let's look at, for your homework, you'd want to look at an injury or an incident that happened in your facility in the last year and try to figure out what were some of the key facts. Or maybe go back and ask yourself, what other questions could I have asked to get down to that root cause? And maybe come up with a rule that you might institute to prevent the type of recurrence. A lot of times, OSHA requires folks to collect accident and injury data, and a lot of times it just gets collected and stuck in a file cabinet. The whole idea of collecting that accident and injury log is to go back and analyze those things and try to figure out what happened and why it happened, and institute something that prevents it from happening again. Luckily, accident investigation, you don't have to be Columbo oftentimes to figure out what happened. I'm going to show you one last one before we go and see if you can figure out what happened and what type of things contributed to this accident. Here we go. Oh, wrong one. All right. So this is as you can see, there's a scaffold there. And what you can't really see really clearly is the guy on the scaffold is holding up a ladder. So let's go take a look, see what happens here. Oh, the scaffold's rolling away. There comes the ladder and the guy on it. And now he's going to come over and give him the Heimlich maneuver. And now if somebody falls 20 feet to the concrete, is the best thing to do is lift them up? Probably not. Probably not, because you could likely have broken bones. So what happened in this thing is, well, what they were using was a rolling scaffold that's on wheels. Now those wheels do have a locking mechanism. As you can see from the scaffold, the scaffold does not have fall protection where the one fellow was standing holding up the ladder. It's not fully planked. And the wheels were probably not locked. Maybe one of them was locked, but it didn't look like it. Now, they also took a ladder and propped it up onto one of those scaffold boards and then had someone climbing up that ladder. So there was a lateral force pushing against the scaffold, and if it's on wheels, if you put a lateral force on basically a rolling scaffold, it will roll. And the other thing you might notice is that a lot of times sidewalks are pitched so that rainwater goes into the street and the gutters. So again, preserve the scene and take pictures, interview people. What were you trying to do? What happened, and collect the information, and then figure out why were we doing it that way. So again, most of us can look at that and see, what went wrong there? A number of things went wrong. So it wasn't just the fact that the scaffold wasn't fully planked, but it may have contributed. It wasn't just the fact that the scaffold did not have standard railings, but that could have contributed to it. The main thing was that the rolling wheels were not locked. And then they were also using a ladder not the way the manufacturer said. The manufacturer says make sure the ladder is on firm and stable ground. That's not firm and stable ground. It's a rolling cart. So as you can see, a number of things went wrong here. And a lot of times that's what happens. If you ask somebody to do a task, a lot of times we overestimate our abilities to do things, and sometimes people improvise, and and they without proper guidance, sometimes people do dangerous things. So that's why we do this analysis, and that's why we have rules at work. So if does anyone have any questions out there that you want to put into the chat room and ask a question? And again, this will be recorded, so you can watch it again. Or if somebody else you think might be helpful by going through something like this, you can have them watch it. Any other questions? And again, if you do have questions, you can email me. My email is art.pennesi, Pennesi, at state.ma.us. And there it is right there. Look at that. And I'll try to answer it. And if I don't, no, again, I'll ask somebody who's smarter than me and find out the answer for you. Like Stephen, oftentimes. So there we have it.
It's just coincidental that I hit that just as soon as you said that.
Yep. Again, even in my short duration doing accident investigation with the department, oftentimes, when we go out, they're really not hard to figure out. If somebody was clearing snow out of a snowblower and they put their hand in the chute and they amputated a couple of fingertips, it's just a matter of, let's do some research on that particular snowblower. Did it come with a guard that would have prevented you from doing that, or did it come with a little tool to help unclog the chute? What did the manufacturer say to do to unclog the chute? And oftentimes it'll say, okay, yeah, you have to turn off the snowblower, turn off the motor, and wait till all the moving parts stop, and then use a tool. Never, never, never stick your hand in the chute. Well, a lot of times, if we, unfortunately, more than once, we've seen snowblower amputations where people have tried to clear the chute and nobody ever told them not to do that. So, or give them the right tools, or maybe the tool that cleared the chute got lost and wasn't replaced. So, those are the type of things that are common that we come across. So hopefully you ask the right questions and you try to get down to the root cause, and a lot of times those questions will get you to a safer place. So don't be afraid to do accident investigations. You may not do a perfect job, but the more you do, the better you'll get, just like anything else. Well, thanks everyone for tuning in, and we'll be repeating this again today at 2 o'clock. So if you think someone could find this helpful, then tune in again. And again, thanks again for coming. And yep, tune in for our other upcoming webinars. I'm sure we'll have some more. We've done some stuff on office ergonomics that are in the archive. We've done electrical safety. We've done slips, trips, and falls. We've done preparing for emergencies and emergency action. So there's a lot of good stuff in there, and we'll be continuing to prepare more. So that is all. And again, thanks again for tuning in.